Hello and welcome everyone to Oneida Molded Plastics webinar of how to reduce time to market during new product development. My name is Steve Thalman. I'm the President and CEO of Oneida. I'll be joined today by David Power, our Vice President of Sales, who will guide you through today's presentation. This webinar is our very first in a series of upcoming webinars that we'll offering to our loyal customers and people new to OMP to provide you with insights and guidance from our perspective to help you build great products. For those of you new to OMP or just getting to know us, OMP is a specialist supplier to the outdoor recreational products industry. We are a full-service partner offering molded plastics, part design, tool building, assembly, decoration, and packaging. We are an end-to-end supplier with deep expertise in plastics. Our people are committed to and enthusiastic about making it easy for our customers to manufacture high-quality outdoor recreational products. So now I'll hand things over to David Power, who will take you through our webinar presentation today. Over to you, David.
Thanks, Steve, for the introduction. And of course, thanks everyone for joining us today and honoring us with your time. I know this is definitely an unusual time of business for everyone now. This may be your first webinar, and it's definitely a new technology medium that we've had to look at to embrace in case this might be the only way that we could share this type of information with you. So we really thank you for joining us. As we focus today, one of our main focuses as we start going through ways to reduce time to market are just going to be some of those simple but often forgotten tips and tricks and processes from our expertise in new product development on ways that we can reduce time to the market. Now, we know that you're going to face a whole lot of new challenges in a new product development. You're going to face things with time constraints, expectations, some of those being realistic expectations, some unrealistic, sometimes even impossible expectations. And then the limitation of resources and having the amount of information that you need going forward. Now, I've got a picture here of Clark Griswold and his family because as I was preparing this webinar information, with our engineering team and everyone, I was also preparing for a vacation trip with my family, and it reminded me how as my wife and 3 daughters, I've having to load up into a van to go on vacation, that we were going to have all those hurdles and speed bumps and delays potentially along the process. And I couldn't help but compare the analogy preparing for my trip as it was for preparing for the challenges of a new product development, along with some of the players and the stereotypes of the participants that we have in new product development in our teams and such. So I looked at it from the analogy of my wife being the project manager. She really planned this trip. She knew where we were going. She had, the basis details. She really didn't care about all the minute details of how we were going to get there. She just expected us to drive and get to the destination. And then I had my sales daughter, I'll call her that. She was more focused on where we were going to stop to eat, and then how picked out restaurants before we even got to the location. And of course, I had my management daughter in the car with me, and she was very impatient. She kept asking all the questions of when we were going to get there, and she wanted to eat where she wanted to eat, or she wanted to do the things her way. And then we had I've got my QA daughter in there who asked a ton of questions, wanted all the details, and made me stop way more times, more often than I had expected to. So some of you may be pointing fingers at each other or thinking about people on the process that are stereotypical in the process development as you go through. Just a funny analogy to have. But knowing for me, since I have experience in taking trips with my family, I knew there was something that I needed to help with, and that was the navigation. So just like in a new product development side, using a navigation system will help on our road trip. So I'm going to use that analogy as we go about knowing the destination, which is an important part, planning the best route, how to use assistance along the way. All those things will help us get there faster. Those are the things that are going to help us plan for the obstacles, plan for the delays, and keep good communication going back and forth throughout the entire part of our journey. Keep us avoiding the traffic jams, the accidents, the police along the way. Really help save a lot of time and keep from the delays. Now, doing all this, you've got to consider that there's milestones to your plastic part journey, just like in our trip, planning checkpoints. So I know that there's going to be a point along my vacation trip that I'm going to have to refuel. So I want to kind of plan that refueling to it can be at the same type of time that I would refuel at the same time that we would also get food and maybe take those bathroom breaks. All necessary things along the trip, but there's key points that will help reduce time in that, and that's what we're going to focus on. Now I'm going to spend a lot of time more at the first three phases of this process about the 3D model, the 3D printed part confirmation, and the frozen design part, because those are really key to our trip. Then we're going to kind of go through some of the milestone expectations of the tool design and build, T1 through T3 samples, and first article runs, and the approvals to production. Now, of course, just like any trip, we've got to check the vehicle out. We've got to make sure that the vehicle that we're going to take has all the necessary resources available for it. So in checking the vehicle out, this is very closely related to how we're going to ensure our access to resources in our plastic project. So in alignment of your resources, you want to make sure that you've got the information ahead of time about the materials, if there's various colors that you may be wanting to do the project in, the added value services that you may want, like decorating or assembly and those things, and all the way to the end of the packaging. So getting those resources lined up front will save a lot of time. Then having a machine shop resources available on site. So this would be very similar to the point of me having an extra toolkit and a spare tire in my vehicle for my trip. Knowing that I've got enough resources that can kind of keep me on the road and minimize my delays are going to help out along the path, just like if we need to design something in that would be finished out in an internal tool shop along the process of your part. And then, of course, preventative maintenance to protect the investment. Knowing that you're going to put a lot of capital expenditures out for a tooling package that you're looking at doing for the process, knowing that someone's going to be there to protect that investment for the long haul would be very much like in my example of making sure that I had an oil change done on my van ahead of time and that my tires were rotated, that I was in the best condition to protect the investment and protect the vehicle that I'm going to use to get to the destination. Also adding things like fixture availability, knowing that I've got everything packed in my vehicle that I'm going to need for when I arrive there, like my bathing suit and those type of sunscreen and items that I'm going to need while I get to the beach is going to be very similar to having fixtures available at your T3 or your production phase of your process. And then also capability of doing running engineering changes and continuous improvement capabilities along the way. Now we've got to do the work. Now, if designing and building just one plastic part was the only thing that you had to do in running a project, it probably wouldn't be as difficult for you to apply all the resources and to pay attention to it. But we know that in this case, that you probably in any process or product that you're trying to work on, that there's multiple other parts are involved. You've got casting parts or MIM or machine parts that you've got to deal with, all to make this unit come to one finalized piece. And the plastic components in your program are just one piece of it, and there obviously usually multiple plastic parts involved with it. So we're going to look at ways that you can use your time and your resources wisely when looking at the entire project, and specifically on the certain areas that we can spend focus on with the plastic components. So there's things that you should be able to expect when you engage your partner in the early design process and design for manufacturing. Things that you should expect to work on, and things that you should expect that you would want to supply to your, give information for your supplier. Like my first point here of share the complete mating part design intent early. So seeing all the other components that are in the process, what this part may made up to, and the entire gun in this example that you would be building are really important parts to understand and get a good 30,000 foot view of the entire product. This will also help with expecting help on the design drawings, the staging, how to design the parts, so that you won't be going down this on your own. You can actually have part of that navigation, and understanding the complete project will help your supplier with the design along with you. And then you've got to prioritize the product characteristics, which parts are critical, That'll be from input as well from your supplier, where you can look at those specific areas that we know and have predictive information that these are the critical areas and this has to work perfectly or work well enough to mate up to another part of the project as well, including some of the design support that you should expect, where you can get help along the areas of gate area options, so you can avoid some of those putting features in that specific area if it's the best place to gate, or parting lines, say things like the fastening ideas. You can expect some input as far as whether this is a good opportunity for a vibration weld or a sonic weld option, all within that same thing of best practices for it. You should also expect some experience with materials and geometry and tolerances to help with that strength and interface applications. So understanding what's the capability of the product as you go through it, and also to address some of those potentials of assemblies coming forward. So is there a metal component that's going to be overmolded? So knowing that type of thing up front will help with some fail-safe issues in the design process, that possibly that part can only be loaded one way in the tooling so that it doesn't crash the tool, or it can, have options for machining operations that go along with it. So understanding that complete potential of assemblies early in the phase will help put some of those fail-safe issues in the design process early. And then you've got your future option capabilities, logo changes, decorating options. This is a point where, maybe you've got a specialty run that you may think of doing, 3 or 4 years from now, or early in the phase, to where you would want to do a special one of a logos for a customer that would give you a big order. Designing that piece in early will help you in the long run and saving times, or a decorating option where we can add weep holes and things to the process or to the product, so that if you want to go to a hydrographic decorating piece later, you don't have to go back and add a weep hole for it to bleed the water off in that process. All those things leave that part design input, help feed directly into the tool design as well. Those things are going to get you some benefits to the early design involvement. Okay, what we see based on our experiences, the ones who have that when you have that early supplier involvement, those programs tend to be more successful. They're usually happen a lot faster, and you get more accurate quotes as well, because all the information has been developed up front and you're not guessing or making assumptions on the product as you're going through. Then that, of course, helps reduce the time of explanations, where you've got question and answers back and forth, where your quote has to have a lot of question marks behind it, and a lot of question and answer time about what the critical areas are, or what the design intent of the product is going to be. And those things will also help a faster response to the critical areas, noting that this is an area that we're going to focus on to make sure that it mates up well with a part, or that we can understand the fact that it's got another hole in it that the pin is going to go through, or those type of things. And that'll help things with the reduced scope creep, which is a term we use a lot when the project seems to kind of veer off into a different direction than was expected. And that will help, of course, with your timetables and your original quotes being more readily met. So when you can set a time for the milestones, realistic expectations can be set on the manufacturer side, and you've got a good, hard type of date that you're targeting. In the design for manufacturing and part and tooling concerns, just knowing the specific application and the components of the industry will help a lot. With the drafts, with putting caution areas in of the geometry, noticing areas that are thin and thick areas, if there's potential sinks, potential from a thick area that there may be, if there's recoil in the product, which is in most of the gun industry, obviously, and where those impact areas are going to be. In addition to that, that helps us with some of that perception of value to the customer in the long run. So we're looking for some of those areas that might be a shiny spot, or whatever, that may give a perception of a lesser quality product, or just in things like grip angles on how they fit and feel with the customer in mind. Things like parting lines and gaps between the product, or just the overall look of it. Those things can all be addressed with potentials in mind as we get through the design for manufacturing side. And of course, you want to deal with your option capabilities, because you're not just building usually one thing for one time. you've got to incorporate some of those inserts and options for things like the left-handed versions or weep holes for decorating. If you start with all those options considered, there's a lot of things that the capability of your tooling may be able to do. I know one of my examples in the past has been, a short action and long action stocks, or an insert for a short action, long action type of unit. So starting knowing that you're going to try to do both versions will give an opportunity up front to have enough real estate in the tools to where you may not have to launch both versions right out of the gate on the tooling, but it would give you the option that you start with a short action and a long action can come later, or vice versa. Just starting with that end in mind will save you thousands of dollars later and a whole lot of time, especially going through the entire process again of trying to rebuild an entire new tool. Now, back to my trip example, one of the things I always love to do is to pack the trunk out or the back of my van out the night before the trip. That way I know what will fit and what I have to tell my daughters they can't take with them because they all want to take 4 or 5 bags apiece. But funny example for that, this is a point where the technology has brought us to a point where we can 3D print and do a part confirmation. So this will help you confirm your models, that the base models that we're using don't have any weird things in them, that it prints pretty well. It can help you check fits, and it can compare some of the interfaces of the parts together. So this is that last bit of where you get that opportunity to print it out. We've got something in our hands that we can share back and forth and see the part, and kind of gives you a good direction of where we're going with the entire process. So all this is really trying to help us push through hard to get to that frozen design. Now, you've got my Christie Brinkley Ferrari here along with the Clark Griswold station wagon, but we all know that sometimes taking the fastest vehicle does you no good if you hit the delays, like getting stuck in a construction delay or traffic, or you get pulled over by the cops. So that's part of this navigation system, is all about trying to look for those obstacles up front. And we don't always have to take just a Ferrari to get there, although it's something we want to try to catch up to. But just pushing that station wagon as hard as we can early in the process will help save us a lot of time in the long run. And that's all through this point, trying to push us to the frozen design support. Okay. Now we've put a lot of time in early supplier development. We've checked all of our resources, and we're getting to that point now to we're at our frozen design support. This is where we get to that bilateral engineering agreement, that both sides, the supplier and the manufacturer, are shaking their heads in the same direction, and everything seems to be going well, and we're all very confident on our design. Okay, we've addressed some of the caution areas that are known. We've helped cut cost out where we can, and we've experienced all we've leveraged all the experience in the components and the design and expertise. So we're in a great situation when we make it to that frozen design point. If we've done all of our work up front, we've really got a good vehicle going forward. And it's real important to do so, and I'll use this chart as an example. If you'll notice on our left, on our y-axis, all the time during the concept requirements and product design, sourcing, and prototyping, all that portion of the graph are really the lower cost impacts of design changes. But once you get past that point, the cost and impact to do design changes after you start getting into the tooling really will delay a process and cost a lot more money. This is a good example of picking the material out front. So let's say you started your process with a glass-filled nylon material, and that's the desired product that you want to go with. But then the tooling's been, you say, well, why don't we look and see what can happen on a polypropylene material, for example. We want to switch back and see what it is. Understanding that all the work up front and all the design and the tooling was all designed around doing it in nylon material, the cost of changing over to a polypropylene or a different material later down the line is going to cost you a lot more in time and money in the process. So we try to avoid those things up front. This is the good time. We all pushed really hard to get through that frozen design so we can get to a point of set it and forget it during the tool build. So by applying the bilateral engineering up front, this will help accelerate the tool build. This is not the time where we have to start and stop back and forth because we're still, got some areas of concern. This is the set it and forget it opportunity. And it's a good opportunity for you at this point to focus on other areas of the project. So you put all the work up front on your plastic components, and now you get more opportunity to work on some of the casting and MIM and other machining type parts of the process while the work is being done in the tool build. This is a time where the features, the actions, and the base of the tool are all being built, and the entire program launch with multiple tool builds can be going on simultaneously. And as long as we're not starting and stopping, because if you hold one tool up for a design change or a piece, it could potentially affect all the other tools that are going through the project. And this could be a big time waster. So we really push hard to get to that set it and forget it phase of a frozen design, and the tool build is launched and going on, and give you some opportunity to work on some other areas. Now, what's going on your tool design and build is it accomplishes some of the things like our fast tool building turnaround time. This is a point where now they're just going at it. We're putting more resources at it to build that tool. We've effectively, we've done an effective tool design, so that helps us with a lower cost of tooling. And we've also figured in some of the things that we could do in-house, like a still safe type of condition that can be groomed in our in-house tool room. We've also applied some of that tribal knowledge about what the part is likely to do because of having the experience of so many things and having over the years of being able to do similar type of programs and parts with it. We also can apply some of that predictive data of flow rates, tool wear, and things that we can address as that's going on. Okay, so this is a little bit of the cruise control. Now, if we take our car off of cruise control on our trip, we've gotten to that point of T1 samples, okay? And some of the goals here of the T1 samples are just an expectation. This is an area of things to expect when you're seeing that. The T1 sample, when we get to that phase, is going to be basically the basic features and the part shape. It's not going to be a textured part. It has no processing applied to it, no capability studies, no fixtures. It's just the raw form, fit, and function. So ultimately, the thing in the milestone to remember on the T1 sample is that its goal is to prove it, that you're on the right track and the textures can be applied, that we're in good shape. And we move over to the T2 samples. So we're getting real close now. The texture's been applied, the tool is on the way to the plant. And if we've done all our work up front and we've addressed all those issues as we talked about, it's saved us time in the long run, we're at a much better part of our journey, because a lot of these parts in this early phase can be used for early phase testing, can be used for show samples, can get to the marketing people so they can take pictures and really start the campaign of the launch of the new program. And that gets us to the T3 production samples. This is the part where the processing is done and the tool is in-house and it's likely running on the machine that it's going to live the rest of its life in. Okay, so it gives it the opportunity to apply the logic, and the setup sheets are developed. Any necessary fixtures are added to control that part as it comes out of the press. And then we can have the opportunity to do larger capability studies, and then we can start correlating our data. And that'll give us the opportunity for our first article samples are available at that point. And we finally reach our destination. We pull into the condominium we're staying at, and this is our approval to production. This is where the data is all correlated. We've addressed the critical areas. Any of the exceptions that needed to be made back and forth of non-critical things are being made, and the details are being worked through that were close in the function of the part. Everything's working well, and the key features are then addressed. By doing all the work up front and each phase of this process, this helps minimize the approval of the approval delays that we sometimes see in programs. Now, just to kind of wrap it up, guys, this is kind of the summary and key takeaways. Remember, the entire basis for this was to figure out how we can help reduce time to market. And we all know that most of the time that's wasted is the time that we didn't plan for delays and we didn't plan for the process. So just some key points just to confirm your resources up front. Make sure that the vehicle that you're using, in my example, is prepared for the trip, that it has all the resources and that you're communicating those resources necessary up front with the process. And then get early supplier involvement as much as you possibly can to get that expertise input to your project up front so we can address all the options and all the concerns and all the things about it. so we can get to that set it and forget it. And then understand the milestones, so you can communicate that information back and forth with your management team and with the rest of the team about where you're at in that process and what the expectation is. Avoid the delays and the time wasting parts of the program, and you will certainly reduce your time to market. So now we've got an opportunity for some question and answers. We've got our panel of engineering and quality on the line with us to directly address any specific questions that you guys have, and we appreciate your opportunity today. And you've got a button at the bottom of your screen that you can submit any questions that you'd like. We'll try to address them as best we can.
Thank you, David. We got 4 questions that have already been submitted. I'll go ahead and field the first one. The first one was, we'll be receiving slides of the presentation afterwards. Actually, we're recording this presentation, so we'll send out a link to the video to everyone that is registered following this webinar. The second was, what about prototype tooling? What ways do prototype tools help speed up time to market?
That's a great question. We hear that often. You know, we get that question a lot. I think to address that, we've got Dave McMahon and John Andrews in engineering, and they can discuss that a little bit further about how we would handle that option in as well. But what a great question. Yeah, John, David, you guys want to take that?
Yeah, sure. Hi, everybody. So prototype opportunities are evaluated typically, you know, on a case-by-case basis, depending on customer requirements or desired use of the prototype. You know, we here at OP have 2 primary offerings. The first being, you know, additive manufacturing or 3D printing. You know, as David had mentioned, you know, these are, you know, physical printed samples of the product, more for proof of concept. You know, we do fused deposition modeling here. You know, typically you can have some samples out within, you know, certainly a couple days in most cases. We do have some local shops or local partners near us that, you know, we can utilize to get some different materials or, you know, our processes, you know, as an offering as well. You know, the second option is, you know, actual molded prototypes from soft tooling. You know, as anything, you know, there's some pros and cons with this approach. You know, this option carries, you know, some higher tooling investment up front. You know, adds a bit of time on the front end, but it does offer prototypes in the parent material or, you know, the specified material off the drawing. May also lack in, you know, thermal processing controls. You may need to machine some features in, you know, afterwards, you know, slots and holes and hole positions to make sure, you know, they fit, form, and function in the upper level assembly. You know, but again, a lot of these opportunities are kind of, you know, evaluated, you know, case by case. Certainly, you know, if anyone has something specific to look at, please reach out to David or myself, and we can go further.
Cool. Great.
Thanks, John. Second question, or third question, how many shots are molds typically good for? And then the second part of that question is, once a mold has met its life cycle, can it be refurbished, or do you need to purchase a new mold?
Okay, John, you and David? Yep.
Yeah, I can do that. You know, we typically warranty our hardened steel that, you know, our H13 is warranty for, I think, 500,000 shots. The soft P20 is 200,000. It really depends on part design. You know, the material being used, the higher the glass, the more wear we typically see. But, you know, where we can and certainly kind of use our expertise. So if we know there's wear surfaces, yeah, and if we're able to insert those and kind of make it a, you know, a PM item or maintenance item, we do that. And then part 2, you know, I guess we have molds that have far exceeded the 500,000 shot. You know, we've had a few of those. You know, it's really just the upkeep and then as far as texture goes, you know, that's kind of done on a case-by-case basis. We've textured a few molds, you know, a few times. You know, they look pretty decent. So again, kind of case by case, but they typically last quite some time.
Yeah, I'll throw one piece in on that too. One of the things, you said generally on a hardened tool, you're looking at that 500,000, piece or 5 years. Along with that, one of the advantages, like I mentioned before, on the kind of the preventative maintenance side of things, is having that capability in house of being able to really manage that tool life and textures and touch up areas along the way. Really are, in my example of the trip, kind of like having the mechanic change your oil. He's looking for all those other little areas of potential problems and things along the way. So that's one of the great advantages that we do have with that.
And the last question is, how fast is a tool build turnaround?
Again, a lot of this stuff is case by case. If we're talking, say, a stock mold, to T1s, you're probably talking 12 to 14 weeks. Some of the smaller components are, in the 8 to 10 week range. It's really, kind of part design and tool design dependent. So.
Yeah, and the point of of course, of putting that early supply up front, getting the early supplier involvement up front, that really is going to dictate a lot of those areas along the way, because the biggest areas we see in tool design delays come from the start and stops, right? Because once you put through that set it and forget it, it's time now that's being worked on. The more effort you put in it up front, the better results you're going to get at the end, and the more time savings you're going to have. Because that middle is kind of is going to be critical based on how many times you have to start and stop on the project. Mm-hmm.
Well, that's all the questions we have.
Okay, great. Well, if that's it, guys, I want to thank you so much. There's my contact information. Please don't hesitate to reach out to us. We are having another live cast event coming up on Tuesday, the 28th. This one we're very excited about. Less of an informational type of session and more of a celebration type of session, where Oneida has been very involved with the Industry Choice Awards. And based on the way the year has gone and us being able to, or having to be separated from contact, we're doing a live broadcast of the announcements of what the 30-plus person evaluation team has selected that we host. So we'll be hosting that for Rifle of the Year, Pistol of the Year, Concealed Carry, all those event categories. So this will be a good celebration time where you'll get to see the reveal and the announcements of what products were selected as from the evaluator team this year. So please be on the lookout for that invitation coming soon. And we really appreciate everyone joining us today. It's a little, it's new to us. So maybe I can't wait for the opportunity when we can sit across from each other again at some point and have a meal, or just be in the office and do this work face to face. Thanks for joining us, guys.